Hello friends. So in continuity of our previous video, we discussed about that consistency of linear equations in two variables. So we discussed that just by comparing these ratios of a1 by a2, b1 by b2 and c1 by c2, so these three ratios in different way in three different cases, when very easily we can check that what type of solution we are going to get. If graphically we are solving it, then what type of solution? In algebraic interpretation is there, then what type of solution we are going to get. And we can also check by that only that whether it will be the pair of linear equation is consistent or inconsistent. So today with some examples we will discuss these three conditions. So earlier I just explained you in my previous video that how to check the consistency of linear equations in two variables. So say if this is a pair of linear equation, the first example, the different three examples I will take for all three different cases. So first case, the pair of linear equation I have written already here. So if I'll find out from this the ratios, so a1 by a2, so a1 you know is the numerical coefficient of variable x and of the first equation, and the numerical coefficient of x of the second equation is a2. So when no value is there, so you can put 1 there, 1 is there, not 0, so it will be 1 by 3. And if I'll find out b1 by b2 here, so it will be minus 2 upon 4, or if we'll cancelled by 2, so it will be negative 1 by 2. So I explained you earlier that if a1 by a2 and b1 by b2 you are not getting equal, like in two cases these both should be equal. So when you are not getting equal, so no need to check then c1 by c2. Don't waste your time in checking that. So you can write here that because a1 by a2 is not equals to b1 by b2, so the first condition applies here, that if graphically we will solve, so we will get intersecting lines. So two lines, the graph when we will represent, so we will get two intersecting lines, they will cut at one point and the coordinates of that point will be the solution of the equation. You know that abscissa and ordinate, when we will do in the next video the graphical method, at that time I will explain you in detail. So if algebraically if we'll solve, so the solution will be the unique solution, and because we are getting the solution, so means this pair of linear equation is consistent. So consistency we have checked that this pair of linear equation is consistent. If algebraically the interpretation is there, so unique solution, and graphical representation is there, so intersecting lines. So in this way very easily we have checked. Now the second example I will take, so in that we will check and we will try to check the second case. The equations I am taking here is 2x plus 3y minus 9. The second one is 2x plus 3y minus 9 equals to 0. That is the first equation. And 4x plus 6y minus 18 equals to 0 is the second equation. Now again quickly we will check the ratio. So a1 by a2, that is equals to 2 upon 4. So 2 ones are 2 twos are, so it will be 1 by 2. if I'll find out b1 by b2, here it is 3 upon 6. 3 ones are 3 twos are, so that is also equals to 1 by 2. Now because we are getting a1 by a2 and b1 by b2, the ratios are same. So definitely we have to find now c1 by c2 also, the ratio of the constant terms. So minus 9 upon minus 18 as per this example. So negative negative cancel, 9 ones are 9 twos are. So this also is equals to half. So now we can say, if we compare these three ratios, so a1 by a2, because it is equals to b1 by b2, is equals to c1 by c2. So as per our table, we know that the second condition applies here. So if graphical representation is there, so what we will get? Coincident lines. Both the lines will intersect at every point, means both the lines will coincide with each other. दोनों एक दूसरे को के अंदर समा जाएंगी, तो हर पॉइंट जो है वो सॉल्यूशन होगा. Because many students, they were asking, sir, you should teach in both the language, English Hindi mix. So बीच बीच में मैं हिंदी में भी बताता रहूँगा. तो दोनों लाइन एक दूसरे के ऊपर ओवरलैप करेंगी, समा जाएंगी, तो हर पॉइंट पे मीट करेंगी. सो दैट्स व्हाई कोइंसिडेंट lines, they are coinciding each other. So because they are intersecting at every point, so algebraical interpretation is, or with algebraic interpretation you can say, is infinitely many solutions, because when every point is a solution, so there is no end for the solution. And because we are getting the solution, so it is consistent. The pair of linear equation, this which is here in the example, is consistent. So this, in my previous video also I explained you that whenever the solution is there, whatever the type of solution, that is different thing, but you are getting a solution, so the pair of linear equation is consistent. That's why we are checking the consistency of the equations. Now for third case, we will take one more example. A pair of linear equation we will take, and we will try to find out the ratios and the condition also, that what we are getting. So the third example I am taking, x plus 2y minus 4. X plus 2y minus 4 equals to 0. That is the first equation. And second, we can take 2x plus 4y minus 12 equals to 0 is the second equation. So again, a pair of linear equation in two variables are with you. So now we'll quickly compare. No variable, no numerical coefficient is there, so you can put 1 there. So it will be 1 by 2. Here b1 by b2, so 2 by 4. So again it is 1 by 2. And c1 by c2 here is minus 4 upon minus 12. So negative negative cancel, 4 ones are 4 threes are. So it will be 1 by 3. Now here if you see that, because we were getting 1 by a by a2 1 by 2 and b by b2 also 1 by 2. So that's why we have taken the ratios of c1 by c2 also. So because these two we are getting equal, but the c1 by c2 ratio is not equals to these two. So the third condition applies here, that a1 by a2 is equals to b1 by b2 is not equals to c1 by c2. And if not equals to c1 by c2, so you know that what we will get? Parallel lines. So parallel lines you are going to get in graphical representation, and in algebraic interpretation you can say, because both the lines will never cut each other. They are parallel lines, so no solution will be there. And when no solution is there, so what we can say that the pair of linear equation is inconsistent. So in this way, three type of questions means very easily you can check that what type of graphical solution you are going to get, what type of algebraic solution algebraically if you'll solve by any of the method, the substitution method or the elimination method, what type of solution we will get, or we will get the solution or not, no solution is there. And when solutions we are getting, so they are consistent. When we are not getting the solution, so pair of linear equation is inconsistent. So I hope that with these three examples, this whole thing, or that how to check the consistency of linear equations in two variables, will be very much clear to you. So in our next video, I will explain you that the next method, that is the graphical method. So we'll apply the condition first, we will check what sort of graph we are going to get, and then how to solve graphically. So that we are going to learn in our next video. So thank you very much. Bye bye. See you.